Okay, in this section 8.4, the topic that we're looking at is direction angles. Okay, so when we begin talking about direction angles, we start with the unit vector. And so if you've got the unit vector, remember the magnitude of the unit vector is 1. Okay, and theta is the angle for that unit vector, which is measured counterclockwise from the x-axis, the positive x-axis, over to the vector. Okay, if that's the case, then the terminal point of view lies on the unit circle, because remember the length of the vector, the magnitude of it is 1, and then the radius of the unit circle is also 1. So the terminal point has to lie on the unit circle, and here's what we've got. So if u in component form is x comma y, right, then you can write the component form of that unit vector as cosine theta comma sine theta. Why? Because remember, cosine is the x-coordinate, right, of the point, the terminal point, and the sine is the y-coordinate. So think back to your unit circle. And then, of course, once you transfer it from this component form to this component form, based on the previous lesson that we looked at, we can now take it from component form and write it like this in linear form. Okay, so that's kind of where this comes from, the unit circle. Now, if that's the way that we can express it for the unit circle, then we can expand this idea, and if we just multiply by the scalar of the magnitude, we can write any vector of a certain direction in this format. Okay, so here's an example. All right, so let's say the angle theta is the direction angle for the vector, and suppose that u is the unit vector with the direction angle of theta. So here, if you've got the vector as ai plus b j, all right, so that's any vector that makes an angle theta with the positive y-axis, then it has the same direction as u, and then you can just write this. So if I take that vector, right, and I do the magnitude times the component form of the unit vector, right, then it becomes that magnitude times the cosine of theta I plus the magnitude times the component sine theta times the component of j. All right, so like for example, let's say I have a vector of length of 3 that makes a 30-degree angle with a positive axis. Then I can write it in this form: 3 times the cosine of 30i plus 3 times the sine of 30j. And of course, cosine of 30 is what? Square root of 3 over 2, and then multiply it times 3. And then sine of 30 is 1/2, and multiply it by 3 over 2. So we can take any vector, and then we can write it in this form with cosine of the horizontal component and sine of the vertical component. Now remember, I and j are just a denotation that denotes that this is the horizontal component of the vector, and the j indicates that this is the vertical component of the vector. All right, so remember our linear form that we had looked at from last time. All right. All right, so that's our linear combination form that we've turned it into. Remember, I and j are just indicators of horizontal and vertical position there. All right. Okay, so now, once we have it in this form, then the direction of the angle can be determined from tangent, because remember, tangent is sine over cosine. Well, what's the sine component, right? That second part of the coefficient of j. And then what's the cosine? The cosine is the coefficient part of the I, or the horizontal component. So it's the vertical component, right? The magnitude times the sine of theta over the horizontal component, the magnitude times the cosine of theta. And then so in short, we just call that b over a, right? So all of this coefficient right here is the a part, and all of this coefficient is the b part, right? So it's the b part over the a part.
Attention please, there has been a report of an emergency.
Okay, so again, we can use b over a from this form to help us to determine what the direction angle is going to be. So let's take a look at some problems now. And so remember, tangent of the angle is equal to b over a. So b over a. All right. Tangent of the angle is equal to b over a, and this is the general form for that vector. The vector in the linear combination form is going to be ai plus bj. All right, that's where your a and your b come from. Okay. All right, so let's take a look and see what it looks like here. So what we want to do is we want to find the direction angle of each vector. So the first vector is 3i plus 3j. 3i plus 3j. Okay, so sketch it out. That's the first thing we want to do so we can get an idea of a picture of what's going on here. So the horizontal component is 3. The vertical component is also 3. And so here is my vector. There's my vector. All right? And so when we take a look at this now, my right triangle is here. I can now use tangent of the angle is equal to b over a in order to find this angle here that'll help me find the direction angle. So when I go to write that out, it can be like this. I'll have tangent of the angle is equal to 3 over 3. So that's b over a, 3 over 3. All right? And so to go and solve this, what I would have to do is I'd take the inverse tangent of both sides. And so when I do, I've got the angle is equal to the inverse tangent of 3 over 3. And so again, we can go into our calculator. And we want to make sure that we're set to degrees on this particular one, by the way. You want to check that. I think it defaults to radians. So we'll go inverse tangent of 3 over 3. And then we can see that my angle here is 45 degrees. Now, you always have to check and make sure that that's the complete angle, because from here to here is 45 degrees, and that is the direction angle from the positive side of the x-axis counterclockwise to the vector. So that is our answer, 45 degrees. All right. The next one now, we're looking at a vector of negative 3i minus 4j. So again, if I'm looking for the direction angle, I need to sketch it out because that's going to give me a complete picture. Because remember, this just kind of gives me the angle inside the triangle. I got to make sure it's complete. So we'll go negative 3 and then negative 4. So that's negative 3 here, negative 4 here. And then there is my vector. There's my right triangle. So my tangent of the angle is going to be equal to b over a, which is negative 4 over negative 3. Okay? So how am I going to find the angle? I have to do the inverse tangent of both sides. Inverse tangent of tangent makes the angle fall out, and then I'm left with the inverse tangent of negative 4 over negative 3. Let's go through and see what that becomes now. So we'll go inverse tangent of negative 4 over negative 3, and then that angle is 53.13. All right. Now, this is not the complete answer because this angle right here is 53.13. But remember, to get the full direction angle, I've got to go from here all the way to the angle. So what I need to do is I need to take this and I need to add 180 degrees to it. So 53.13 plus 180, that will give me the full direction angle, which is 233.13. Because remember, the direction angle has to be described from the positive axis all the way, positive x-axis, all the way around to the vector in order to make sure that we can have a separate direction for any vector, right? Because otherwise, this one would be 53, this one would be 53. You see what I mean? Every quadrant would have a 53. So we can't do that. So we've got to make sure that every direction is unique, based on 360 degrees, not just 90 degrees, not just a quarter of it. All right. More practice doing the same thing. Find the direction angle, and so in the next one, go ahead and draw it out. And that's what drawing it out does. It helps you see what you need to do to get the complete direction angle. That's why it's important to draw it out. So -3 and +7. So there's my vector. +7, -3. All right. And so when I write it out with tangent, it's going to be tangent of the angle is equal to 7 divided by -3. I'll do inverse tangent of both sides. 7 over -3. Calculator will give me that angle. And so we'll go, if I can get there. There we go. 7 over -3 is what I want, so that is 66.8. 66.8. All right. So that means this angle is 66.8. And so what do we need to do in order to get this angle? Well, I'm going to have to go 180 minus 66.8. So 180 minus 66.8, all right, equals 113.2. So 113.2 is going to be my direction angle there, right? So remember, when you first come up with this, the angle that you get is the angle inside the triangle, and you've got to use that to see if you need to add or subtract from it to get the full direction angle, okay? So be careful with finishing that up. Draw the last one now. All right, so it has a direction of 4, -5, so we'll go over 4, down 5. Here's my triangle. All right, so when I write it in, we got tangent of theta is equal to, and it's got to be, remember it's b over a, so -5 over 4. So I'll do inverse tangent to both sides. So I need the inverse tangent of -5 over 4. That will give us the angle. So we've got -5 over 4. So that is 51.34. 51.34. All right. And remember, what angle is that? That's the angle inside the triangle. So how am I going to use that to get the full direction angle? I'll have to do 360 minus 51.34. And so we'll get 308. 308.7. All right, so the question may arise, Coach, why do I get a negative angle right here on this one, and why do we get a negative angle on the last one? Well, remember, with sine, cosine, and tangent, when you plug those in, the angle that you're going to be getting is from, it's based on from 0 to 90, right? Okay. And so here, this is the angle in the negative direction, right, for 51. So that's why it comes out negative, but we can just write all of those as positive angles.
Attention, please,
okay.
Students and teachers. Thank you again, students, for coming to school every day.
Okay, so like I say, that is the angle in the negative direction, but remember, you can just know that that angle inside that triangle, regardless of which way it's turned, is 51.34, and the question becomes, well, what do I need to do with that 51.34 to turn it into the direction angle in the counterclockwise direction from the positive x-axis? The answer is all the way around 360 minus that 51.34, and then there's the full direction angle. All right? So that's it.